maybe we need to shall I share this again? Maybe we need to share this code again. Okay, so we learn something new again. So before learning this, I want you to answer some questions related to last class. Okay, we have maybe 2.5 minutes. So here's a question. Which of the following statements are correct? A is static member variables live throughout lifetime of the program. B is static member variables are shared by all objects of the same class. C is static member functions cannot access non-static member variables. D is static member functions can call any member functions. Okay. Okay. Let's check the results. Some of you received the money. 有没有同学收到红包啊？我让他尝试了一下红包功能啊。So we can see here. So some students get the right answer, but not so many actually. D is wrong. Actually, the static member function, this is very special function. You can just regard it as a general function, right? A general function. For example, if you define in class A a static function f, you can just regard it as a general function, or you, for example, is f like that. I mean, this function actually does not is not much attached to this class A. Okay. It's a general function actually. Okay. So this general function has no access to this pointer. This general function has no access to this pointer. No access to this pointer. So cannot access member functions. Cannot access member functions or non-static member functions. Right. This is the reason. Okay. Another question. What's the output of the program? Again, 2.5 minutes. We can see here we have a class test, then we have a static variable here, and then we have the constructor of this class, and then we have destructor. In the constructor, we -1 to the static, and in destructor we in constructor we +1, and in destructor we -1, right? Then this is a static member function to get the results. Then we use new to define two objects, and then we use delete to free one, and then we want to know number, right? Number, and then return. Still someone not submitted results. Okay, we can see here, most students choose the correct answer. So this question tests the constructor call and destructor call, right? So you can see here, if we define the object in this way, a constructor is called, right, once. So when we call this once, this count initially 0, this here it will be 1, right? Then here another object is created, another call of this constructor. So this count is 2. And when we delete 1, this destructor is called. So the number of count is -1, right? So it's -1 is 1. So when we print it, it should be 1, right? So this is static, unstatic. Okay. Okay. Now let's learn something related to composition and inheritance. Okay. First of all, we want to emphasize something related to object-oriented programming. So in our object-oriented programming, the key, I think the key is I think the key is code reuse. Code reuse is the key in our object-oriented programming, because we have learned classes, right? We use classes to define different objects, right, with different values. So this is also code reuse. And now we learn something more effective in code reuse. That is to create new classes based on old classes. So this is very good reuse of old classes because the old class may have already been well tested, no bugs, very good design, very good classes, very good functionality. So why not reuse it in our new classes if possible, right? So this is very good design. Always incrementally define your new class so that few bugs will be introduced. So this is the key of this OOP design. So always try to reuse your old code because this code should have been well tested, right? I believe if you are a designer, I believe you have tested it well. Then you can incrementally define new classes. So this is the key, okay? So how to support this kind of code reuse? We have two grammars. One is composition, another one is inheritance. And more importantly, today we will learn two. And more importantly, there is a template. Actually, template is different from composition and inheritance because composition and inheritance are, we use it to define new class. However, this template are patterns of classes with no parameter types. That means you can use this pattern and give it some parameter type, for example, int. We may have a pattern of class A, pattern class A. If you give it a int, then you get an int A. If you give it a float, you get a float A. Like that. So there's a pattern has no parameters, types. Then you can provide parameter types to get new classes. So it's like that. So that's different, right? Different way. So today we will learn this composition and the inheritance. The composition has a relationship because old class defines the member objects or member variables of the new class. So old class objects composed the new class, right? So inheritance is creating the new class by inheritance. We'll learn this later, right? Okay, first composition. So actually, we have already used composition before. We used the composition to define a class with built-in types, right? Built-in types. So we use built-in types to define some, if we can name it objects, we use built-in type objects to compose a new class, right? So we have already used composition in this way, okay? So for composition, we have two types. One is public composition, another one is private composition. Actually, we can also have a protected composition, but similar to private composition, but difference is that if we do inheritance, that there is some difference. Okay, let's have 5 minutes break. Okay, let's continue our class. So we have 15 minutes. Okay, then we just mentioned that actually there are 3 ways of composition. One is public, another one is private, and the third one is protected. But this protected is less used. So, and also we need to learn protected later when we learn inheritance. So we have to learn it later, okay? typically there are two ways, public and private. Okay? So here's an example. We have a class X, and then this constructor, the member function set, member function rate, and permute. Sorry. And then we use class Y, define class Y, the new class, reuse the old class as public member to define public member object. So in this way, it is public composition, right? Public composition. Then we can define a new object. Then we can, because the object is public, so we can directly access this member, and we can directly access the member's interface, right? Set. So this is public composition. Another one is private composition. This idea is very simple. We have to define the private members like this. Then because it is private, we cannot access, in Y we cannot access X directly. So we have to define some interface, right? So to define this interface, and we call this the X permute. Right? Then we in Y, using Y object, we just call this newly defined member function. Okay, and this is two ways of compositions. First one is public object, public member object. We can directly access. Okay. Yes, sure. You can do assignment because it can be arrow value. Okay. Because this can be arrow value, so you can assign you can assign the other objects to this object. Okay. And for this private member, we have to define new interface because we cannot directly access this object. So this is private composition. We have to define some new interface. Okay. So here's an example. We have the class car, and there's some engine, wheel, and window and door. These are different classes. So using these classes, we can define a new class that is composed of engine and four wheels and left door and right door. And then we can directly access the left door and the window and roll up like that. So because this is public composition, right? Public composition, we can directly access all the objects. To select between different composition methods, there are some rules. For example, if the class user is allowed to access the members of the new class, then we should use public composition, because in this way we can access directly the members, right? So since the public member objects has its own access control, right? So safety is still guaranteed to some extent, right? So for class users, knowing how the class is composed helps understanding the usage of new class. So for the user, it's maybe more clear, right? And otherwise, if it's not the case, then it's suggested to use method number 2. That is, we use private composition, and then we define some new interfaces for the users. From semantic point of view, there are two types of composition. One is aggregation, another one is composition. So actually in our book, beginning CPP 17, in this book, the author calls this composition, actually the author typically call aggregation. However, in our thinking in CPP, this book, the author called it composition. So we still use composition, but we need to know some fine difference between the two words or the two notation. Difference is that if the child object can exist independently of its parent object, the relation is called aggregation. Otherwise, it is called composition. That means it's a very fine difference, right? So that for example, if we have the previous car and wheel, apparently wheel class can exist without car, right? Because it is often, for example, some factory may manufacture this wheel, right, without car. Okay, so this class can exist without the parent class, right? Example of composition is book and page, right? Without a book, what is page for? So page cannot exist without book, right? So this is an example of composition. There's fine difference between them, and we still can. There are two ways of defining these members. One way is using pointer members, right? We can use, for example, we have class A, and in this class A, we can define a B by pointers, right? And we can define B2, right? And which is not a pointer, right? So there are two ways of defining the members. And pointers are often used, actually. Especially in some case, pointers are necessary because we just learned that OF stream cannot have be passed by value, right? So in this case, a class cannot have an OF stream. Let me check. A class cannot have a OF stream member, I think, member object. Typically, we use OF stream pointer or OF stream reference, right? Because if we have OF stream member object, then how to initialize this object? We need to copy, right? Actually, copy constructor is disabled, so there's no way to do that. So we have to use OF stream pointer or OF stream reference in another class. If we want to write some logs, okay. Okay. Then object construction and composition. For composition, our question is why not depend on default constructor? So this is because member objects of the existing class may need to be initialized with specific values. And also for the member objects, there may not be default constructors. So we need to explicitly construct the member objects. So the grammar is a member initializer list or constructor externalizer list. So this is grammar. We have a new class and we have some members of existing class, and then we can use this. So it's similar to initialize member variables, right? Like this, similar to that. So this is then in this way we call the constructor of the of this exist class, like this. Okay, so this is initializer list. So it's similar to built-in types, and also we know that we have already learned that const and reference members are always initialized in this list, right? And if a class composed of more than one member objects, the member objects are constructed in some order, right? So this order is the same as how the member objects are declared in the class. It's not affected by the constructor list, right? And member objects of destructor are destructed in the reverse order of their construction. It's like the stack. I just mentioned it's like the stack. Right. Okay, this is composition, and let's check. Now we have the inheritance. Okay, now we have inheritance. So we know that we all inherit something from our parents, our behavior, our appearance, even some, some treasure, some money, right? We inherit from our parents, and maybe in the future, right? We inherit something, right? Properties. So it's similar to class inheritance, actually, very similar. So in this example, we can see here. So maybe in the class, in shape, every shape should have some member like area and get area function like that. So then all these shapes inherit these member variables and member functions, right? And also for staff in the Tsinghua University, maybe I think all of them have some salary, right? Then this is also inherited to all the staffs and in this university. So this is inheritance, right? This is inheritance. So there are 3 ways of inheritance. One is public inheritance, private inheritance, and protected inheritance. Public inheritance is mostly used. Protected are seldom used, actually. So this is grammar. So for public base class, if we public inheritance, then public members in the base class remain public, and protected members of the base class remain protected. Private members inherited but not accessible. So we can see here for all the 3 different ways of inheritance, all the private members are not accessible in the derived class. We cannot access it. So if you are the class designer, you do not want your members, some of your members, to be accessed by your future derived classes, you just define it as private. Then for protected inheritance, all public and protected become protected. Then for private inheritance, all public and protected members become private. Okay, so this is the rule. Public and protected, actually protected, the access control protected is similar to private. Okay, that means you cannot, from the object of this class, you cannot directly access this protected member. Okay. So protected is similar to private. Protected is similar to private. Very good question. If we cannot access it, why should we inherit it? Very good question. Remember that we still have some public members, right? These public members we have inherited this. Some public members maybe can access these private members. So we can use these public members to access these members. We still have some way. It's like a key, right? Maybe our parents have some money, and then they are afraid if they give all the money to us, we may use it up, right? So they just put the key to someone else, right? Then you can use someone else's key to access this money, right? So it's like that. So then this is inheritance. Okay. Then there is an example. We need to stop here. Okay, let's continue our class. From next class, we learn this public inheritance and different inheritance methods. So we have one rule here, right? We learned from last class that here, if the members of the base class are private, then in the derived class, there's no way to access this part, right? No way to access this part. So this is the I think this is the rule or the grammar. If you want this part to be accessed, if you want to access this part, you have to make it protected or public, right? So this is only way you can access it. However, if you make it protected, for example, some people argue that this violates the encapsulation or data hiding rule, right? We know this data hiding is the key feature of OOP. So, for example, if you make it protected, then it is accessible in the derived class. Then, for example, if this base class is designed by Tom designed this base class, and Robert designed the derived class. Maybe in the future, Tom find out that, okay, this name convention is not good. He wants to make it better naming convention like this, just modify this name. Then Robert will find, oh, my code cannot be compiled, right? There are compiling errors. This is maybe Robert should not like it, right? So I think this is one of the features of the data hiding. If you can hide it, then you don't have to worry about this, right? You just modify your private data as much as you want. You do not need to worry about other dependent issues, right? So I think this, if you make it protected, then this violates the data hiding feature. So it's up to you because if you are the designer, it's up to you to freely design it, but keep in mind that protected and public actually violates this data hiding feature. Okay, so this is what's left in the last class. Then we take a more detailed look on this public inheritance. This is the grammar, this public keyword here. Then the base class is look like this, and then if we do public inheritance, then this basic or the base part is inherited without modifying the access control. That means if we do public inheritance, original feature that is accessible outside the class are still accessible in this, still accessible. Okay, then if you want to define some new members and new interface, that's still okay. So this is public inheritance. So by public inheritance, we inherit all the base objects and the base interfaces as is. It looks like original version, right? So by this public inheritance, the interfaces are still accessible. So it looks like the basic object is still there, right? You can still use this derived class object as if it is a base class object. Okay, so this is public inheritance. Okay, this is public inheritance. And this is why it follows is a relationship. Okay, this is why it follows is a relationship. Sorry, is a relationship. So where an object of base class can be used, an object of derived class can also be used because the interfaces are there, right? it can be accessed as if it is a base class object. So this is public inheritance. This is the most important features about this. Okay, here's an example. I don't think so. If we do protected inheritance, then this part will be protected. That means if this is protected, that means we cannot access it from outside, because protected behaves similarly to private. So we cannot access from outside. So in that case, this object cannot look like the base object, right? So this is public inheritance. Only public inheritance follows is-a relationship. Protected and private inheritance does not follow this is-a relationship. Okay. Then here's an example. This is a very simple example. Due to time limit, actually we have the code, but you can play with it. Okay, so from this example, you can see here we have the private member I, and then in the derived class public inheritance, we have another I. Actually, there's two I, right? Two variable I in the base and the derived class. So now, actually, in this class, we have two variables named I. One is xi, another one is yi, right? Then in this derived class, we can call the base class in this way. And this is grammar related thing. And this one actually will override because we have the same name function in the base class. And then if we call this function from the derived object, this one will be called because it's override the base version. We will learn this later. We also we will learn this. There's something related to name hiding. We will learn this later. Okay, then from the testing, we can see that the size of the X and size of Y are different. I think this should be 4 bytes and this should be 8 bytes because there's one I in here and there are two I's, right? We just mentioned that there are two I's. One is Xi, another one is Yi. So the size is larger. And then these are the grammars. If we call this function like this, then we'll call the derived version. And if we want to call the base version, this is the way. Okay, and this is grammar. And here's the memory layout. We mentioned that actually in the object of the derived class, we have two I's. And actually the functions actually are not in the object layout. We mentioned about this before, I think. This memory only contains the data. Actually, the functions are listed in another part of the memory, functions, okay? And this data will be stored in one part. The functions will be stored in another part because functions are code, right? If we learn, when we learn the assembly language, it's ASM, we will learn this later. We'll know better about this code segment and the data segment. They are stored in different parts of the memory, okay? And this that is the data layout of the object. And then here are some grammars on constructor in inheritance. Similar to composition, so we can call base class constructor in this way. And these are the way to call the constructor of the member objects, right? So both composition and inheritance will be the constructor of them will be initialized in the constructor initializer list or member initializer list. Okay, then this is simple grammar. Order of the construction and destruction. We just need to memorize it, I think. First is the base class object, and then is the derived class object. This is the order of the construction. And then the destruction is in the reverse order. Okay? Reverse order. So here is an example showing how the objects are being constructed and destructed. And here is a smart way of defining many different classes using macro. So this macro is interesting. If you have interest, you can try to understand it. Okay, actually, this ID is the key, right? So in this way, you can easily define many different classes. Right? Many different classes only has a class name inside, right? And also constructor and destructor in this way, right? So define many different classes, base, member 1, member 2, like that. And then we can define the derived class, derived 1, and also derived 2. So we mentioned about that. The order of the construction does not depend on the constructor initializer list. It depends on how the members are declared in the class. So it depends on this, right? And this. So this is to check the order of the construction and destruction, right? So when we define a derived object, then at the end of the scope, this object will be deleted. So destructor will be called. So first constructor and then destructor, right? So this is the output. We also have some source code for you to play with. So you can download from our web learning. But due to time limit, I won't go into detail about this. And this is the order of the output. The first one is the base, right? And then because derived 2 first inherits from derived 1, and derived 1 inherits from base. So first is the base, and then it is member 1, member 2. After member 1 and member 2 are constructed, then we are ready to construct derived 2, right? We are ready to construct derived, derived 1. Because these are constructed, so we are ready to construct derived 1. When derived 1 is constructed, then we are ready to, when this one is constructed, then we will construct member 3 and member 4, and then derived 2, right? Member 3, member 4, derived 2. Then all this object will be constructed. Then this destruction is in the reverse order. Okay, so this is to test the order of the construction and destruction. So there's an there's an interesting usage of this construction and destruction. For example, if you you have some functions, function like that, if you want to monitor or print something at the beginning of the function call and at the end of function call, you can just have some kind of object. Maybe you have a class, for example, you just have the base class, right? Base 1, define object here. Then you just print something in the constructor of the base 1. Then this way, or you can for example, you can give the function name inside at the for the constructor. And then in this way, when the function is to the end, then you guarantee that something will be printed because destructor of this object will be called. So the destructor will be called and something will be printed from the destructor. So this is a way to keep a record of which functions are called when you execute your program. Okay, so some trick based on this constructor and destructor, because you know that at the end of the scope it will be called anyway. Right. Okay, then this is order of construction, destruction. It's very simple and easy to understand, I think. And here's some limitations about inheritance. First one is that constructor will not be inherited. This means that the base constructor cannot replace derived constructor. So if you do not define a derived constructor, compiler will help us to generate one, but compiler will not directly inherit base constructor and use the base constructor as our derived constructor. There's no way to do that. So this means we do not inherit this constructor. Okay, so doesn't mean that we cannot call the base constructor. We can still call the base constructor, but we cannot use it directly as a derived constructor. Okay, similar for the destructor, we still cannot directly use it for derived objects. Then for assignment operator is similarly, we cannot directly inherit it. If we want to do some assignment between derived objects, we cannot depend on the assignment operator defined in the base object or base class. Okay, so these are the special operators and constructor destructor that cannot be inherited directly. We have to define it by our own hand. Okay. Then there are some keyword final. There's keyword final. Final means we just learn inheritance. We use final to disable inheritance. So if we define some class A, we do not want the others to inherit from our class A. Then we just define it as final, as final. Then we cannot do that. We cannot inherit from class A. And if we want class C to be final, we can do it derived class. We can do it in this way. So we cannot inherit a derived class. And also we can disable a member function to be overridden. We just we know that we can, in the derived class, we can define the same version of the base class, like this. In the class C inherits B, and in C we define exactly the same function. This is allowed. However, if we define it as final, then there will be compiling errors. Okay, so this is a keyword final. Now let's have a example subtyping. For this subtyping, actually for this knowledge or this notation, we have a corresponding example. Our example is that we want to create a new type of ifstream object. So this object not only opens a file, but also stores other related features, such as file name. We may think of two ways. One way is to use composition, another way is to use inheritance, right? So for composition, we know that we need to define a member of ifstream, right? Like this. Then we can store some file name, whether this name is it's already named or not, things like that. So in this way, we can even add some automatic type conversion like that. However, even we add the type conversion, this still does not work. We cannot use the file object as if it is an IF stream object. So for an IF stream object, we know that we can close it in this way, right? In this way. However, by using composition, there's no way to do that, because composition, either a private composition or public composition, does not follow is-a relationship, right? It follows has-a relationship. Follows has-a relationship. So an fname1 object is not an ifstream object. So the interface of the ifstream cannot be used directly. Okay, so this is composition. We cannot do that. But we can use public inheritance to do that. So public inheritance actually enables us to define some subtype of an existing type. For this example, we can define a subtype of upstream as a file name. File name 2, maybe, right? You can define it in this way. So this is a very interesting usage, I think. Even we do not know how is upstream defined in the standard library. We do not know that, right? But we can do public inheritance from this upstream. And we are sure, by public inheritance, we are sure that this class, this derived class, has all the interfaces of this upstream. We are sure about that because we are using public inheritance. Okay, so this is a very interesting example and very useful, I think. So the new type has exactly the same interfaces because we use public inheritance. And new members can still be added if we want. And it follows is a or is a type of relationship. This means whenever the new type, the new type can be used wherever the existing type is used. Okay, so this is a very interesting example. So we can have a look at the example. So we can see here, actually we have two different main functions. And we wrote still again, we have this kind of thing. Okay, anyway. So we have main.cpp and main.cxx. And then we use view card. This is a special version of this makefile if we want to use different suffix to make different targets. We can make two targets, composition run and inherit run like this. And then we can write it in this way. Okay? So if you have interest, you can have a look about this. And then this target, this all target, default target depends on the two new targets. And then we can compile the two different targets separately. Okay, so this is how we write such kind of makefile. If you have interest, you can have a look. So it's already compiled. This is the composition version. And this is the inheritance version. So we can see here, we inherit from upstream to make a derived class. Then we can add new members as we want. And in the new member, in the new in the derived class, the constructor is defined like this. So similar grammar, right? So originally, so this is the, because we have this base class, so we will construct it in the constructor initializer list. So because for upstream, we will open the upstream object in this way. So we use it in this way. Okay? Then is I think then we can open a file, and then we can use it as if it is an upstream object. So we can use getLine, because getLine function takes an upstream object. So wherever the upstream object can be used, the file name2 object can also be used, because we have all the interfaces of the upstream. We can even use 6G to move the file pointer, right? File stream pointer to different places. We can also close the file in this way. So in this way, we define a subtype of the upstream, right? Upname2 is a upstream object. Okay, so this is very interesting example, and if you can learn it and use it, I think this is your OOP design technique or skill is really good. If you can understand and use inheritance in this way, even we do not know how the base file or base class is defined, we still can use it in this way, right? So this very interesting example. I hope you can you can understand it and try it. Okay. So this is a public inheritance, and then we learned something about private inheritance. So for private inheritance, we still inherit. Yeah, I think so. This is for getLine. We will do some. Actually, we will do some upcasting. We will learn upcasting later. We are upcasting from fname2 to upstream inference, upstream reference. fname2 reference to upstream reference, I think. We're upcasting the reference. Okay. So this is anyway, we can wherever the base object is used, we can use a derived object if we follow public inheritance. Now this is the rule. Okay, and this is the rule. And for private inheritance, because if we do private inheritance, this interface becomes private. So we can never access this part of this part of interface directly. And also the private part, no access, right? We know that. So because we do not have the same interface in the inherited version or derived version, it does not follow is-a relationship. Does not follow is-a relationship. So where the base object can be used, derived object cannot be used. Okay, so this is the private inheritance. So private inheritance actually represents its implementing in terms of, because anyways, we can inherit something into the derived object, so we can access it when we define the member functions of the derived class. So we can still implement some functionality based on the base class functions, right? Or base class interfaces. However, if we want to implement something based on an existing class, private inheritance is not the only way or the only method. We can usually use, or we can always use, maybe in many cases or most cases, composition is enough. We can use composition to implement in terms of. Right? And sometimes, if we really want to use this private inheritance, we may think of this. Sometimes we may hide some interfaces of the base class. Sometimes we want to, by default, we will hide, right? By default, we will hide the interfaces of base class. And if we want to expose some interfaces, then we can have some grammar. We can have this kind of grammar using. Okay. Here's an example. So we have base class pet, then we have some public members like this, public interface. Then we can define a derived class by private inheritance. So by default, if we do not have a keyword here, it will be by default private inheritance. Then if we want to still, because these interfaces are hidden, right? Because this, after private inheritance, they become private. So if we still want them to be accessible from outside the class, we can use the keyword using, like this, using. So in this way, we can do this by defining this derived object. From the derived object, we can access the interface this way, right? Because speak is not exposed, so we cannot access speak. So this is grammar of private inheritance, and actually we can access freely in this. If we define, for example, we have some function inside this derived class, like this. So in this class, in this function, we can, in this member function, we can freely access the base interfaces, these interfaces. Okay, we can freely access these interfaces in our member function of the derived class. So we can implement some function in terms of the base interface. Okay. So this is an inheritance table. Looks very complicated, but actually it's not so complicated. You can see here, this part is the access control in the base class. Access control of the base class. And this is the inheritance method, public inheritance, private inheritance, and protected inheritance. So this is the access control of the members in the base class. Okay. So we can see here, this part gives whether member functions of the derived class can access members of the base class. So this means if we do public inheritance, we cannot access private part of the base class. We will learn that in the last class, right? So private members of the base class cannot be accessed even you use different private members cannot be accessed for any of the different inheritance methods. Private members of the base class cannot be accessed, right? So this is a table. And the other members are always accessible in the member functions if we define the member functions of the derived class. Other members are all accessible, right? All accessible. So this way, from this we can understand that this private guarantees the private guarantees the data hiding, right? Data hiding. We really hide this data even in inheritance. Okay, let's have a 5 minutes break.大家现在有问题的话，也可以课间提问啊，包括其他的问题，比如说大作业呀、代码阅读啊，相关的问题都可以问啊。Okay, let's continue our class.刚才有同学问到蓝色的那个，蓝色这个是就是继承的意思啊，我没太看明白这个问题啊，就是蓝色这个是继承的方法，就是这个比如 class A 这个，蓝色这个箭头是吧？so the blue arrows are used for whether objects of derived class can access inherited members defined in base class. For example, if we have this class B inherits public, maybe we just take this, okay? It's public. This, for example, is private, right? So this means whether this object can directly access this base member. Just exactly this meaning, okay? Exactly this. So this means from outside the class, outside class is to access it by object, okay? So this is the meaning, okay? This blue part in this. So whether the derived object, if we use the derived class to define some object, whether this object can access the members in the base class, okay? So this is the difference. For public inheritance, all the access control keeps unchanged. If we do private inheritance, all the base members becomes private. Okay? So in this case, we cannot access it, right? Because it is private. So if we have protected inheritance, still we cannot access because they are protected and private. Protected are similar to private if we access from objects, right? So we still cannot access these members, okay? Okay. Then a multiple inheritance is actually a derived class can have many as many direct base class as requires, as you want. So we can define different number of base classes. So we can inherit from different base classes into this new derived class. So there comes some problems with this multiple inheritance. This is duplication. For example, if we, in this class we have member named the density, and we have a function or interface named the get density. Then in another class we also have a density and also has the get density function. Then if we have a derived class from these two base classes, then there will be some errors. We don't know. In fact, we don't know which function you want to call, right? The compiler cannot determine. So in this case, we have two solutions for this. One solution is to apparently or explicitly call this base class member, right? In this way, right? This way we can distinguish between them. So another way is to do a casting, right? We cast, we static cast from the derived class object to a base class object. This is by reference casting, right? Cast this derived object reference to base object reference, right? In this case, the compiler knows, okay, you want to call these functions or these classes member function, right? Then this duplication is solved. Why reference? Because reference is why reference? Well, why not? I think reference is very good candidate, right? Because we have learned reference, and reference is const pointer, right? And I think from now on, I suggest you to use reference, right, as much as possible instead of pointers, okay? Because we have learned reference, and reference is safe compared to pointer, okay? 就是引用其实更安全一些。我们学了这个引用之后哈。So actually we did not learn this cast. Actually, we have different cast methods that is used to convert, to do conversion from one type to another type. Right? We can do this kind of conversion. Actually, we also have this upcasting. We will learn later, and we have this static cast. This is to cast from one type to another type, but they have to be related types. And there are some rules. You cannot cast directly from class A to class B if they are not related. However, you can cast from derived class, this is derived class, to a base class in this way. Because it is public inheritance. A derived object is a base object, right? So we can do this kind of casting, okay? And for this multiple inheritance, actually we have this diamond inheritance problem. So this diamond inheritance means we have one base class here, and from one path we can inherit the members from this base class, this one path, and we have another path to inherit the same members, right? So this gets a diamond shape. So we will have the confusion which part or which path we have, or which path is exactly we want. So in this case, if we do not have any solution to this, there will be many copies, right? 2 copies of base class, right? And then if we want to solve this problem, we can use keyword virtual, keyword virtual. So if we use keyword virtual, this ensures that only a single object of the base class will be inherited into the derived class. So we put a virtual here and also put a virtual here. And then we know that because this is the derived class, from this derived class has 2 common classes as the base class. So because they have virtual, so we know that only 1 copy of these base class objects will be inherited into this class. Okay, so this is the multiple inheritance. I think in the data structure class, you may need to use this effect of virtual. We just mentioned that ensures that only one sub-object. Otherwise, there will be two copies, right? Because there are two passes. So one pass is from this box and then carton, and then into this class. Another pass is the contents, from the contents to this class. So there are two passes to inherit this common class. As compiler, if we have the virtual keyword here, the compiler does not need to worry about the pass. Compiler only worry about, okay, I have one copy, that's fine. Okay. Do not need to worry about pass, right? Because anyways, you only have one copy, right? Only one copy of the common of the base class object. So there's no need to worry about that. Yes, for this virtual, this keyword, we will learn this later. Actually, this keyword is for a polymorphism. This very important keyword, right? Sorry, morphism. We will learn this later. This is very important keyword. So this keyword, virtual, can also be used to solve this diamond problem, inheritance problem. It is also a keyword for polymorphism. Okay, we will learn later. Okay, so we have learned this inheritance, and we suggest you to use inheritance and composition to support this kind of incremental development. So by incremental development, we always depend on existing code, right? And use existing classes, because these classes are well-defined and well-tested, and we know that there's no bugs or mostly no bugs. So we are safe to use existing code, right? And then we can incrementally develop more applications. So this is, I think this is a key. We do code reuse, right? By OOP design, we do code reuse. This is the key, right? Like by code reuse, we can incrementally develop our system. And in this way, we can easily develop some prototype system, and also this support some kind of agile development. Actually, this is I don't want to mention too much about that. If you have interest, you can learn more by yourself. So this agile development is a hot topic, and nowadays we want to make things faster, and so we want to make prototype system faster, right? We develop such kind of system faster so that we can get the feedbacks from the users, right? And then we can incrementally refine our system, right? So this is agile development. Okay. Then we have a new example here. So we have this class, base class pet, and then we have public inheritance, and we define a function like this. Actually, in the base class, we also have two functions like this. Then let's check this, whether this works. So this works, and this works. This no, this works. So if we want to access the interfaces from the derived object, this it works, but this sleep does not work. There's two versions in the base class does not work. So actually this is called name hiding. Okay? So we'll learn this in next class. Okay.